Hi, this is John C. Murphy. Welcome to the iPhone Programming 101 course, which is a follow-up to my Objective-C 101 course. This first lesson is intended to serve as a review and a brief summary of that course. I will be using the metronome sample code, which creates this ticking metronome thing. The source code for this is found on Apple's sample code website for the iPhone. If you sort by title, then go down to metronome, you can download the files. If you open the directory, what you will find is the main project file with a .xcode proj extension, all the source code in the classes directory, this English language project directory which contains the nib files which I will explain. There are images that the app loads, even sounds. It's a complicated project, I know, but that's why I use it. You know, it's fine to start out with a Hello World app where you type in your name and it says hello, but that won't get you very far. This metronome app, on the other hand, is one that I have consistently found useful when trying to figure out how to do things on the iPhone. The program that you use to open and edit iPhone projects is called Xcode, and it contains the iPhone SDK, which is a collection of tools for creating iPhone software. This can all be downloaded for free from Apple. When you first start looking at a piece of sample code like this, you have to understand how projects are typically laid out if you want to be able to figure out what's going on in it. This Groups and Files list on the left displays everything that Xcode needs to create the final application. And don't be overwhelmed by the size of the list, because most of this stuff is not your problem, it's Xcode's. For instance, the Frameworks folder. A great deal of code in any iPhone application that you create is not yours, and you never actually see it. It is supplied by Apple as a binary object that is already loaded on the iPhone, and to which your application links at runtime. You access it in your code by including these code libraries called frameworks into your source code and writing your code in accordance with a predefined standard syntax called an API. The framework APIs are written in Objective-C, which is the language you'll be programming in, so it won't feel too different. For this next section, I will go over some definitions. The first thing we have to be clear about is what programming is. Simply put, programming or development involves typing a bunch of words or code into a text editor and then running that code through a program called a compiler, which tries to make sense of what you typed in and convert it into something that a computer can understand and execute or run. Now, you can't just type in anything you want into the text editor. It has to adhere to a specific set of rules. That is, it has to be in a known programming language in order for the compiler to be able to successfully interpret it. If you didn't have the compiler, you would have to write everything in assembly code or machine language, which is difficult to say the least. Object-oriented programming is one of the recognized programming styles or paradigms that can be used to describe a particular approach to programming. For the most part, this just affects the layout of the project and its data structures, though by extension it can refer to the programmer's mindset while designing the application. So if you write your code as a straightforward list of instructions organized into functions and function calls, then you're using the procedural paradigm. But if you organize your code into separate classes that each provide a discrete portion of the program's total functionality, then you're doing object-oriented programming. The CPU doesn't care either way, since everything winds up as a list of instructions anyway. Objective-C is the primary language used in iPhone programming. Think of it as the C programming language with a few extensions that make it easier to do object-oriented programming. Though they look differently, behind the scenes they are very similar. The main syntactical differences are the @ symbol, which differentiates Objective-C keywords from C keywords, and the brackets, which I will get into later. So what are the objects in object-oriented programming? These, of course, are not physical objects, but conceptual objects, used to better organize a program with the intent of making the programming process flow more smoothly. There are two ways that objects are commonly discussed. One would be at the conceptual level, where you look at the total functionality of a program and organize it into groups of related tasks and interactions between these groups. These groups of related functions can be considered as separate objects, and their interactions can be mapped out like this. Just doing this can greatly facilitate the design process, but more importantly, this outline can be used to separate the source code into blocks of related functionality called classes, which not only makes the code easier to read, but more importantly, the compiler will be able to map each class into its own distinct area of the memory. This allows you to refer to that block of code by name and to use its functionality in this manner. For instance, in the root view controller class, we have this toggle view function, which is what causes these two views to be swapped when you press one of these buttons. The front view is created by a class called metronome view, the other side is called preferences view. As you can see, the entire metronome view class and all of its functionality are accessible to the programmer through this one word, metronome view controller, which is the instance name given to the metronome view controller class up here. So classes in the source code become objects at runtime, that is, an area of memory that can be addressed and interacted with as a single unit. Each class usually gets its own file in the project. The exception to this is what's called a protocol, which I will address later. In fact, each class is supposed to be placed into two separate files, one which acts like a table of contents in that it contains a summary or declarations of all of the variables, properties, and methods of the class, and the other file contains the details or definitions of everything from the first file, as well as any other stuff that is appropriate for that class. The reason it's done this way is a holdover from the C language, where the order in which the compiler read things was significant, so the declarations were placed at the top or head of the file in order to be read first, followed by the definitions. As projects got bigger, it made sense to separate the declarations out into their own file called a header, which is the reason for the .h extension. Let me give some more examples of why classes are useful. In Metronome, you have this Preferences view, which is all the stuff within this gray area. It just contains a table view. So if we look at the Preferences view class, we're not surprised to find that it only contains the code for a table view. As was mentioned, however, the real significance of packaging it up this way is that it allows us to refer to that block of code by its name, and the compiler will actually be able to find it. So when we are designing the user interface in Interface Builder, and we come to the space that we want to be filled with the code from the Preferences view class, all we have to do is tell it the name of the class, and that code will be inserted. The same thing is true for the Metronome view class. Now, an object doesn't have to come from a class that you write yourself. It can also come from the frameworks. Take, for instance, this line in Metronome view. This is a declaration of a UI image view object, which will be named Metronome ARM. The UI image view class is available to any class that has this statement in it, which adds the entire UI kit or Cocoa Touch framework to the list of files that the compiler will search when trying to interpret the words UI image view. So what belongs within a class? Two things: the code for the class's functions or methods, and space for the data needed to accomplish those methods, which takes the form of variables, or more accurately instance variables, also known as data members. The methods for any framework class are listed in its documentation. The instance variables are not, but you can infer a lot from the properties. For example, a UI image view would need to contain an image. Now, if you need to know specifically what the public members of a class are, then you have to find the header file on your hard drive. But this isn't normally necessary. At this point, I should clarify a couple distinctions. First, objects are the runtime realizations of the class that they represent. The other distinction that I need to make is between a class and an instance of a class. An instance is the in-memory representation of a class at runtime. I will get to this more later, but understand for now that when an application is executed, the RAM memory will contain both the instructions, or text, for how the program is to be run, as well as the program's data, which is the organized memory spaces required to carry out those instructions. So an instance of a class is the memory structure that corresponds to that class. The reason that the distinction is made between a class and its instance is because a program can have more than one instance of a particular class. For example, in Metronome view, notice that there are two instances of the sound effect class, one for the tick sound and one for the tock sound. Notice that the only difference between them is the audio file which is loaded into the class's memory space. The sound effects class is very simple. It just has a couple initialization methods and the play method, which obviously causes the sound to be played by the operating system. And it has a single instance variable called sound ID, which we can see here is just a pointer to that audio data file. The beauty of this setup is evident in the play sound method, which is triggered each time the arm reaches one of the extremes of its movement. This method runs some logic to decide which sound effect should be played, and then it sends a play message to the correct instance of the sound effect class. So the use of this sound effects class is a pretty good example of why objects are useful in programming. You may also have noticed that there are two instances of the UI image view class, which is different from the sound effects class, which is a custom class, meaning the project contains the actual source code for it, while UI image view is a UI kit framework class that the project has access through the inclusion of this line. Metronome view uses the UI image view class to create an instance of a UI image view object, loaded with this picture, and names the whole thing Metronome ARM, which can be called later when setting up the image of the metronome. To find out about the UI image view class, we check the documentation by Alt or Option clicking in the name, which brings up the documentation. We see that each instance will have all the properties and methods listed here, as well as all of the properties and methods of the UI image view's three parent classes, UI view, UI responder, and NS object. We'll go over subclassing in a minute, But for now, just know that all of these classes go into forming the UI image view class. These methods are used by the metronome view class to position the image on the display. You may have noticed all of the asterisks that appear in Objective-C code. These are pointers, not multiplication symbols. Actually, the pointer is the thing that comes after the asterisk, and it just means that the most practical way to refer to an object in the memory is by its memory address. The asterisk tells the compiler to do that. Sometimes it's not appropriate to use a pointer, particularly if the instance variable being referred to is smaller than a 32-bit or 4-byte address, in which case you might as well use the value itself. That's why simple data types like this floating point integer, this unsigned integer object, and these booleans don't have asterisks in front of them. In case you're wondering what properties are, Objective-C version 2.0 introduced properties, which are really just instance variables, with a simplified accessor syntax, meaning it's easier to get access to the values stored in a particular data member. That's all. For example, this particular instance of UI image view uses the center property to set the initial position of the image on the display, which is inherited by UI image view from its parent or superclass UI view. And we can see that this property sets the position of the image on the screen and can be repeatedly changed to create the illusion of motion. Prior to properties, all interactions with a class were done using message syntax, that is, the brackets that Objective-C is famous for. So if you wanted a class to perform one of its methods, you would send it a message in the form of object name space method, all enclosed in brackets. This means that you address the object by name and tell it the method that you want performed. Kind of like if you have a roommate named Joe, the syntax for getting Joe to wake up would be Joe, wake up. So for instance, most classes have a variation of this line in them, which interpreted says super, that is the parent or superclass, initialize yourself. A class can also send a message to itself, as in self, do something, which may seem a little bit silly, but it ensures a consistent syntax. While this syntax may make sense for methods, it doesn't make much sense for properties, so they gave us dot syntax, which is what many other languages use to specify properties. Getting back to the topic of project layout, notice that many classes have either view or controller in their name. This is because it is recommended that Objective-C projects be organized in accordance with the model view controller paradigm, which essentially states that you should treat your user interface as its own entity, not just as the visible manifestation of the underlying data model, which leads to ugly, difficult-to-update software. At this point, MVC is pretty much the norm, and it's built into the entire UIKit framework, so if you just go with the flow, your projects will just naturally end up in MVC form. Another word that you commonly see is delegation, which, just like in real life, is a nice word for dumping work on somebody else. So in Objective-C, delegation is the process whereby one class leaves work for another class to complete on its behalf. You will find that delegation occurs very naturally in iPhone programming. Often you don't realize that you're doing it. I think this would be an example of delegation, because this class receives a toggle view message from the button being pressed, but it doesn't do anything with it other than pass it on up to the root view controller class. And this brings up an important point, that often the purpose of delegation is to avoid subclassing. So let's discuss what subclassing is and why you would want to avoid it. Inheritance and subclassing are the process whereby you create a new class based on another one. Pretty simple, right? Recall that UI image view is a subclass of UI view. That means that the in-memory data structure for UI image view also contains the UI view class. Furthermore, since UI view is a subclass of UI responder, which in turn is a subclass of NSObject, that means that they are all contained within the UI image view class. In fact, inheritance is an integral part of the frameworks that you will be using in iPhone development, and every class will inherit from NSObject and perhaps several other classes as well. Note that Objective-C supports multi-level inheritance, which is what you see here. Each class inherits from a superclass in a chain, but it doesn't support multiple inheritance, which would be simultaneously inheriting from more than one class. The syntax is simple for creating a subclass. Here we see Preferences View Controllers being made a subclass of UI View Controller, which is available as part of the UIKit framework, which is included up here. This all sounds great. You can get a bunch of free stuff just by tacking on the name of another class to the class name that you're building. But you have to be careful when you start linking classes together like this, since they become highly dependent on each other. In fact, in practice, developers tend to avoid using inheritance in their own projects due to this interdependency. Notice here in the metronome's view controller structure that they avoided the use of subclassing through delegation. You have these two buttons, the info button on the metronome view and the done button on the preferences view, both of which need to trigger the same method, toggle view, the code for which is located here in the root view controller class. So why even bother with implementing toggle view at all in the Preferences View Controller class? Why not just make it a subclass of Root View Controller and let it forward the toggle view message up there? Well, let's try it. Make Preferences View Controller a subclass of Root View Controller. You need to fully import the parent class in order for this to work, and then comment out the toggle view method declaration and its definition, so there's no direct reference to the toggle view method within this class. Now when we run it, we see that the Preferences view is able to find the toggle view method, but the Root View Controller class is not able to implement it correctly. It runs the animation, but the views aren't swapped properly. Now you could get this to work, but it's a headache, and it demonstrates why it's easier to have the Preferences View Controller receive the toggle view message and then just turn around and delegate it back to the Root View Controller class. Since subclassing is a headache in Objective-C, the language has some additional syntax to help you avoid it, namely categories and extensions, which allow you to add methods to an existing class. In Metronome View, you have both a category and an extension, or anonymous category. The purpose of this is because the class has only one non-framework message that it is willing to receive. In other words, it has one public method declared in the header. But what about all these other internal methods implemented within the Metronome View class, the ones that it uses when it says things like self, do something, remember that? Without the category declaration, we would get a warning like this one issued by the compiler since it doesn't see any declaration for these methods. The use of the category syntax effectively makes these methods private, that is, only used by this class. Another way that Objective-C allows you to avoid subclassing is through the use of protocols. These are the things in the angle brackets. Unlike categories, protocols allow for the use of methods that are not associated with any specific class hierarchy. So here you have the AppDelegate class implementing a bunch of table view methods that really have nothing to do with the AppDelegate class itself. But we don't have a separate table view file, so the protocol lets us just stick them in the most logical spot, which is the AppDelegate class. We've talked about how a running program needs to map out certain areas of the memory to house the various instances of the objects that it uses to accomplish its goals. But what about when it no longer needs that object? Ideally, the operating system would reclaim that unused space automatically, that is, it would perform garbage collection, but that is not available at present on the iPhone, so applications have to manage the memory space allotted to them. An object is removed from memory when another object sends it a release message. It can't release itself, but an object can only be safely released when no other objects are depending on its existence, which means that you have to keep track of this through reference counting. This is a rather obtuse topic, and I don't think you need to drive yourself crazy trying to memorize these rules. The reason being that even if you do have a memory leak on the iPhone, it usually isn't a big deal because iPhone apps usually don't run long enough or churn enough data to allow leaked memory to become a problem. So you're better off leaving this one alone in the beginning. Consider this example. Metronome's Preferences view consists of a table view object and a nav bar at the top. Once the time signature has been chosen, there's no need to keep this stuff in memory. But how do you safely do that? Where do we put the release message? In this case, it looks like it should go right here in the toggle view method of Root View Controller after the Preferences view is removed from the display. Let's try that. Build and go. It seems to be working okay, as long as the user doesn't try to access it a second time, in which case the app crashes. If we look at the debugger output, we see it's due to the infamous bad access error, which is what happens when you try to access something in memory that isn't there. Of course, we could make this work if we had to, but is it worth it? You can worry about leaks when you're about to put your app up on the App Store. This is the end of Part 1.